I will be recording this and I will post it like I always do for all of your tests, right? So I try to give you guys a really fair review to help you because I always appreciated it whenever my instructors did that for me. And I could never stand when they would give you a test and it was like nothing like what you studied, right? That's like the most frustrating thing. So I always want to try to help you guys out by doing that. Okay. So this is no, they are not inverses because they do not reflect the line y equals x. We could also use ordered pairs to help us to determine that. On number 2, this is a great example of a yes. You can see that the line is reflected across y equals x. And if I wanted to check a few ordered pairs, this ordered pair is 0, 2. And if I flip that, I'd be looking for 2, 0, which is right there. So yes, this shows inverses compared to the other one where it didn't. And you can always check ordered pairs to help. Are there any questions on the first 2? I've got my little notes in front of me, but I didn't turn my page, so. Okay, great. We're gonna get into this next question, which is an ordered, ordered pairs and inverses. So I want to give you a moment to think about this, and then please type into the chat, what do you think about this question? What do you think the answer is? Coming from section 4.1, which was all about inverses, but I'll be honest, it's been a long time since we've studied this because then we took a test and then we started doing exponential and logs. So I completely understand. So just a reminder that if you have x comma y, to find the inverse, you just change the ordered pairs to y comma x. It is not 1-to-1 if on the original if the y's repeat. So I have negative 16, 13, and 11. So we're good. That just means that there does exist an inverse. And then I would just take these ordered pairs and I would change the order of them. So this is x, y. I'm going to change it to y comma x. So I just take the ordered pairs and I go like this. That's it. And when I do that, this is what it would look like. And then I can see that that would definitely be answer choice. Oh, you got to really watch the signs here, right? So this would be A. Yeah. So I think that somebody said C in the chat, but I think it's because they just went a little too fast. Because the reason why it can't be C is because the 13 is not negative, right? So we have to like really carefully look at all the choices there and make sure the signs are correct, because even I thought it was C for a second. All right, are there any questions on the graphs or the ordered pairs? All right, and thumbs up. Is it okay for me to keep going? I did post this to Canvas, so hopefully you're able to print it. Okay, awesome. All right, so let's try this one. It says, what is the inverse activity of setting a clock forward by 1 hour? Please type into the chat what would be the inverse of that activity. We talked about how the inverse is the opposite. It's like whenever I turn my car on and I drive to school and then I park and then I turn it off, right? We do inverses all the time. So I'll give you a moment to please type into the chat what you think that would be. All right, you guys are great, and you are very fast at typing. So it says, what is the inverse activity of setting a clock forward by 1 hour? We would set the clock backward by an hour, or something of that sort would be the inverse operation. And this question is multiple choice, so like you'll have like choices to pick from, but it's kind of like when we spring forward and we move the clock forward and then we fall back, and we just recently move the clock back, but they are saying that that might end and we might just keep it the way it is, which is kind of crazy. So I think that they're still debating that. It hasn't completely been determined. All right, let's try number 5, which says find the function value. Okay, so now just a heads up that all of those first 4 questions were on 4.1. So 1 through 4 was section 4.1, and now we're moving on to 4.2, which is exponential like introduction. So it says find the function value. If the result is irrational, round your answer to the nearest thousandth. Okay, that would be 3 decimal places if that is irrational. So I have let f of x equal 1/3 to the x power. Find f at 2. All right, so f at 2 would equal, and this is when I just take 2 and I plug it in for my exponent, so it would look like this. And then you got to be careful here because when you do this, you end up with 1/9, which is actually not irrational. Okay, it would be irrational if it was a decimal that we couldn't convert to a fraction. Or it was something like pi or e. So we just end up with 1/9. We don't even have to type that in to the nearest thousandth because it's not irrational. If it can be written as a fraction, it is not irrational. And if you type it into your calculator and you get a decimal, there should be a key on your calculator that will convert it to a fraction. But it really is just 1/3 times 1/3. And then 1 times 1 is 1, and 3 times 3 is 9. If you wanted to do it by hand. But there are some that we're not able to do by hand. Okay, like the next one. So let's try number 6. I'm going to give you a moment to try number 6. Please type your answer into the chat so I know that you're there and you're participating. And thumbs up. Is it okay for me to go? You guys are good? Wonderful. Okay, please try number 6. Please type your answer into the chat. We will have to round to the nearest thousandth because we can't turn it into a fraction, okay? So this is where the rounding is really important, all right? So when I did 2 raised to the 2.51 power, I get approximately, let me do this in a different color, I get 5.6962000782. Okay, obviously I don't have to go that far out, but you catch what we get, right? So what I'm supposed to do is the nearest thousandth is 3 decimal places. So if you remember, I go to that 3rd decimal place, which is right here, and then I have to look at the neighbor to the right. If the neighbor is 5 or more, that would change it to a 7. But since it's 2, it's going to remain a 6, right? So this would be 5.696. That is how I would round it. So just keep that in mind. The nearest thousandth, we're talking about 3 decimal places. We take a look at that 4th number to see if we go up or down. Are there any questions on rounding? All right, let's try this next one. I want to give you a few moments to try it, and you can feel free to type your answer into the chat, but we're definitely going to go over it. All right, I am going to show my work for this. So there's actually more than one way to do this problem because we didn't know about logs yet, but I could use a log to solve this. But since this is coming from section 4.2, they actually want us to change the base on the 16. So I could choose to solve this by creating 2 to the 4th power, which of course is 16, right? And then, so I replace the 16 with 2 to the 4th, and then we have this one-to-one property where we can just set our exponents equal to each other. So it would look like that. And then I would just solve for x. And so if I'm trying to get x by itself, I could subtract 12, and then I get -8 equals -4 times x. Then I divide both sides by 4, -4, sorry, and I end up with x equals 2. So 2 would be my answer for that one. So I created 16, I changed it to 2 to the 4th power. If I wanted to use the change of base formula, so if you wanted to solve using logs, you could do the log of 16 over the log of 2 is equal to the exponent. And then this part here would just become a 4, and you would have that same equation. So you could use a log to solve it, but we had not learned about logs just yet. So I know that what they're wanting you to do is actually to rewrite the base. All right, are there any questions on number 7? And remember, if you are shy and you don't want to speak up, you can always ask at the end, right? So I always try to make sure to do that for you. Okay, thumbs up. Can we keep going? You guys good? We're going to get into the word problems. Exciting. Okay. Oh, wait, not yet. It's after this one. My bad. Okay. So on this, we have, it's a similar situation to the one we just had, except for now we have the natural base on both sides. So this kind of looks scary, but it's really not that bad. What I can do is I can just, that's just negative 4 times x. So this is just a power to a power. And so we can just write this as e to the 4 times negative x, which is negative 4x. That's kind of a little tricky, I would say. But we do have the same bases, so now we can just set these equal to each other. So I would have 2x minus 1 is equal to negative 4x. And then I would subtract 2x from both sides. I'm just trying to get my x's by themselves. And that would give me negative 6x equals negative 1. Divide both sides by negative 6. I end up with 1 over 6. And a good way to check this would be to type that back into your calculator. And you would see that the left and right are the same. And I can show you what decimal that would look like. Hold on. There we go. Okay, so we end up with 1/6, and then if I wanted to check it, I could just plug it into the original. So I would have e raised to the 2 times 1/6 minus 1 should equal e to the 4 times negative 1/6, right? And so I would just type that into my calculator, which I am trying to do right now. I'm having a little bit of difficulty because my other calculator lost its battery, which is not cool. Let's see. Okay. There we go. You should get 0.53, 5134 on both sides. So if you're trying to check that, you should get 0.5134 on both sides. But the good news is you're able to just set the exponents equal to each other and solve. And they are trying to trick you right here with this, right? We have to remember that when we raise a power to a power, we multiply. And so that becomes e to the negative 4x, which is what I did right there. And I think we may have had one like that previously, like on our homework, something very similar. All right, any questions on that one? And thumbs up, is it okay for me to move on? Okay, it's good? Okay. All right, now we're getting into the word problems. So these are really good problems. Unfortunately, sometimes students mess up on them on their test. So I just want to give you a few reminders, right? So when we talk about money compounded, so we're talking about compounded interest, we have a special formula that we use for that in mathematics. And if you remember, this is what it looks like. We're going to have this formula, and this should be in your notes already, but we have A equals P, which is just like our initial investment times 1 plus R, which is the interest rate, divided by N, which is the number of times it's compounded per year, raised to the power of time times N. Okay, so let me just declare all these variables for you. So A is our future amount. P is our initial investment. Some people call that the principal, but that's just what we're investing initially. R is our interest rate, but you have to get rid of the percent. And then you'll notice that N is in the formula twice. So N is the number of times the interest is compounded annually. And they usually will give you a word, right? So just a reminder, if they give you quarterly, that would be 12. If they said weekly, that would be 52. And quarterly, what am I doing? That would be monthly. I'm sorry. Quarterly would be 4, right? 4 quarters in a dollar. That's silly. Monthly is 12. My bad. Okay, so monthly would be 12. So we have quarterly is 4, weekly would be 52 weeks a year, monthly would be 12 months a year, and semi-annually, which they sometimes use that word, would be 2. That could also be biannually. And then of course, if they just use the word annually, that would be 1. Whew. Daily would be 365. I don't think we have any of those on your test. Yeah, we don't, so we're good. Okay, so that kind of clears that out. And then of course, T is the time in years. All right, so it says find the future value of $5,170 invested for 10 years at 6% compounded quarterly. Okay, that's a lot of good words there that we need. So my initial amount is $5,170. My time is 10. My interest rate is 6%, but if I move that to the left too, it's 0.06. And then N, since they gave us the word quarterly, is 4. Okay, now I'm ready for the formula. So the future value is equal to my initial amount, which is just the P in the formula, 1 plus 0.06 divided by 4, raised to 10 times 4. Okay, and then of course here, or you could go ahead and multiply that out and put 40. Okay, that's your choice. Because what happens is some people put 10.4 and then they get this answer and they're upset about it. Okay, so I want to give you a moment. I'm challenging you now to please type this into your calculator. You have to have a calculator for this problem. You cannot do this by hand. And try to come up with that amount. I'm going to give you a few minutes to do it, and I'm going to show you what it looks like in my calculator as well. So this is the answer you should get when you type it into your calculator. Now I'm going to go to my calculator to show you what it looks like. Okay, so if you did not get this answer, we're going to try to figure out what happened. Is another one that you're going to have. So I'll give you a few minutes to please try it, and then of course we'll go over it. All right, so I appreciate you that typed into the chat. It seemed like it looks like everybody that typed it into the chat got it correct, so good job. So I tried to show you all of my little steps that I did. I just declared all the different variables for the formula, and then I just plugged it in. I was very careful, of course, in my calculator. It's easy to make a little mistake when you're typing it in, but you should have a scientific calculator which has parentheses, and so you should be able to type it all in at once, and so you're not having to do it piece by piece, because that would make it way more challenging. Once again though, if you're having any issues with your calculator and you want to stay on, I can try to help you the best I can. You can like hold it up like, you know, like that if you need to. and I can try to look at it the best that we can. All right, are there any questions before we move on? And thumbs up, is it okay if we move on? Thank you, thank you, thank you. Okay, perfect. All right, so we've got one more like that, and then we move into different ones. Okay, so please try this one. I'll give you a few minutes to try it, and then of course I'll probably do a similar thing where I'll start to show my work in about a minute or two. So just all right, so I showed my work for you, and I ended up with this answer, and then I want to round it to the nearest cent, which would be 2 decimal places. So I would look to the 8 to see if I round up or down. And since it's greater than 5, I'm definitely going to have to round up. So my final answer would be $7,867.12. Are there any questions on that one? Okay, and thumbs up. Is it okay for us to move on? You guys good? We're gonna move into that next section. Okay, so that was all like 4.2, including the applications, and now we're gonna be moving into logs, which will be the rest of chapter 4. Okay, so let's try this first one. Okay, so you're just gonna be writing this in logarithmic form, and that is a very important skill to have in this class for all the different things that we do with logs. So just a reminder on how to write something in logarithmic form. So if I had this, I would write this as the log of 16 base 4 equals 2. Now, what's kind of crazy is that this question is multiple choice, but people miss it because it's multiple choice, right? Because for some reason that confuses students more, right, when they have those kind of choices, all right? So you're just going to make sure that your base is your little number, and then your exponent should be on the other side of the equal sign, and then the answer part would be in that location, right? And so you're just going to make sure that you are understanding that and good to go. So if I gave you another one, like a to the b is equal to y, then, and you wrote this as a log, you would just have the log of y base a equals b, right? And what's cool is you can always, whatever you think it is, you can write it the opposite form. So I would start with the 4, and then it would be 4 squared equals 16. And then this would be a to the b is equal to y. So you can always like write it in one form and then try to redo it to the opposite form and see if that's like a match. Any questions on that one? All right, and are you guys ready to move on? We good? Okay, cool. All right, I'm gonna give you a moment to try this one. I appreciate that you guys did the correct first step, some of you for sure. So we want to rewrite it as an exponent, and then it is asking us to solve. So I would rewrite it first as an exponent, and then that will help me to solve. So this would be x cubed is equal to 64. But since I'm trying to solve it, I need to go a little bit farther. So to solve it, since it's x cubed, the opposite of cubed is the cube root, right? So I'm going to have to do the cube root of both sides. So I'll do the cube root here, and I'll do the cube root there, and I'll end up with x equals 4, right? And I could check that by plugging it back in, so it would look like this. And then I could either use a calculator to check this, or I could, rewrite it and see if it's true. So 4 cubed is 64. Yay. Fun stuff. We're getting into the fun stuff. Okay, so we have a few more that are similar to those. Is it okay for me to click? You guys good? Questions? Okay, all right, let's keep moving on. Let's try number 14. So same thing, I'll give you a few minutes to try it. I will say, please write this as a fraction, not a decimal. So I'll give you a moment to try it. Good. So I write this as an exponent. 5 to the negative third is equal to x, which is the perfect first step. So I appreciate that some of you typed that into the chat first. That is correct. Good job. That's a very important skill. Then I can just calculate this. I can use a calculator to help me. I could try to do this by hand. It would just be 1 over 5 cubed, which is 1 over 125. If you use a calculator and it gives you a decimal, you're just going to want to convert that back to a fraction. And if you don't have a calculator that does that, you can think of this as 1 over 5 cubed, since this is negative. And then that would just be 1 over 5 times 5 times 5, which is how we end up with 125. All right, we have one more like this, and then we're going to move into the properties of logs, and we're going to try to cover that today. So I'm going to go ahead and move to the next question. I'm going to give you a few minutes to please try this one. Feel free to send me a message. Looks like you guys are on the right track. So once again, I'm going to write it as an exponent first. So I always start with that little part, right? That's my base. So I have x plus 8 to the first power equals 17. And since it's x plus 8 to the first power, that's kind of nice because that's just x plus 8. So then I just have x plus 8 equals 17. And so I can just solve this by subtracting 8 from both sides, and I end up with x equals 9, which is what many of you had already placed in the chat. And if I wanted to check it, I could plug it in. It would be the log of 9 plus 8, 17 equals 1. And then if I worked that out, this would be a 17. And then I would have 17 to the first power equals 17, which is totally true. So you can always plug that in to check it. All right, so the one other main topic I want to make sure we cover today are properties of logs, because tomorrow we'll be reviewing the really crazy, hardest problems you'll have in college algebra that we had on Thursday, right? Those are pretty intense problems. And as your exit ticket, I could tell that some of you were really struggling with those, and they take a while per problem. So we're going to go ahead and do properties of logs, and we have a few questions for that. I think there are 3. Okay, yeah, there are 3. Okay, so we're going to do 3 more together today. All right, let's try this one. It says, use the property of logs to rewrite the expression. Simplify if possible, assume all variables represent positive numbers. Okay, so just a reminder, if you have the log of AB, that could be written as the log of A plus the log of B. If you have the log of A over B, that could be written as the log of A minus the log of B. If you have the log of A to the 4th power, that could be written as 4 times the log of A. All right, so all we're doing is we're using those properties, those log properties, to rewrite this log. So we're going to write it as an expansion using really the sum and difference of logs. And, of course, that power property where we can move it to the front. Okay, so let me rewrite this, and then I will show you what I'm talking about, because the next problem you're going to get to try on your own. Okay, so this is just a reminder of these types of problems. So I'm going to break this apart. I'm going to have 2 times the log of x base 5. Okay, and so what I've done is that represents this right here. Notice I can move the 2 to the front, right? So the exponent on the x, I move to the front. All right, then since the y to the 6th power is also on the top or on the numerator, I'm going to put a plus. And since the exponent has a 6, I can put a 6 here. So it would look like that. And then right here it means minus, right? So when we have that division of logs, we can think of it as a minus. And then I would just have the log of 4 base 5. This question is multiple choice, by the way. So you're going to want to carefully look at your multiple choice questions, like to see which one matches. All right, now I'm really excited about this next problem because it is similar, but it's more challenging. And if you really, really, really understand, you're going to get it right. I feel like I should make it like maybe I'll make it a bonus or something for now. Of course, it's on your test and it's not a bonus, but just to see how you're doing and because that's fun. Okay, so on this next question, I'm going to give you 5 points extra credit. It will go in our participation grade for this week. If you get it right before I do it. And also, I know that it's hard to type this in, but just use the word log, and we can just all assume that the base is what the base is. You don't have to put the log of the little tiny thing, right? Just as long as you get the properties part. Okay, so here's what it looks like. I'm going to give you some time to try it. I can only give you a certain amount of time because, you know, we're on a schedule here. So I'm going to give you until, how about 10:14? So I'll give you 3 minutes. Sorry. Well, you know what? How about 4 minutes? I'll give you 4 minutes. If you can type it in correct into the chat before I start to do it, I will give you extra credit. Okay, ready, go. Okay, so let's work this problem out, and then I will talk about this part here because this one is actually crazy. You're gonna see. Now I'm still gonna give you the extra credit if you didn't do the very last step, okay? Because you got what I was really, really looking for here, okay? So, but let me go ahead and work this out. I would start with the log base b, and then because this is m squared, I can put a 2 in front, and then I would have m, and p to the 4th is also on the top, so I'm going to have plus, so it would look like that. Okay, so that's the first part, right? And then I have, after that, I have this division, and anything that's in the denominator has to have a minus in front of it. Remember, the minus shows it is in the denominators. That's very important. All right, so I have minus, and then 9 log of n base b minus 5 log of b base b. Okay, now I will accept this answer, but I do want to show you what happens because this right here is a 1, right? Because what this says is b raised to what power equals b. That's just a 1. And that's actually one of our properties, one of our other properties. Okay, so this actually changes to a 1. And then I just have this whole thing hold on, I'm almost done. It's kind of a tedious problem. And then minus 5. Now, if you had this, yes, I will give you extra credit. But you got to be careful on your test because it appears you're going to get to simplify at least one of your pieces. And it will simplify to 1. So it might be like the log of c base c. That equals 1. Okay, are there any questions on that crazy one? Oh my goodness, that was crazy, right? Kind of intense. That's good though. Okay, so we're going to do one more today. We'll save the rest for tomorrow because even though there aren't that many tomorrow, they take forever. All right, so last one, we're going to write it as a single log. So this is kind of like doing the opposite of what we just did. Okay, so I want to give you a moment to try it, and then of course we're going to talk about it. Okay, so when I write this as a single log, we're just doing the opposite of what we were doing before. We're taking this equation and we're trying to make it smaller. And so I am going to write the word log base 4, and then this 5 will go back to being its exponent, right? So just remember that's what happens with the number in front. We can put it back on the exponent. And then since it's a plus, that's going to imply multiplication. So I would have a times here. And then this 2 is going to go back on the exponent. But even though this is multiplication, it's not necessary to draw a multiplication symbol per se because it is assumed that if we have 2 parentheses next to each other like that, the operation is multiplication. So this would be my answer. This one is also multiple choice, so you want to look for the answer that matches. But like I said, they're not going to necessarily put a times there. Remember, that would be assumed. All right, we're going to stop there and save the rest for tomorrow because the rest are super duper intense.